I'd like to welcome you guys to the Beck Technology Deprofiler webinar series. My name is Michael Boren. I'm the Director of Research and Development for Beck Technology. And I thought what we do this week is present something a little different than what you've seen before. So if you'll kind of bear with me, we're going to kind of take a little bit of a left turn and talk about some new technology and a new service that Beck Technology has created and is offering. So this service and technology we are coining optioneering. It's a term that a lot of you might have heard before, and really what I'd like to do is talk to you about what it can do, a little bit about how it works, and talk to you about the service that we've built around it. So to start with, just a little bit about what the optioneer can do for you. With this new technology and this service, we are now able to literally evaluate millions of different design alternatives in less than one day. We can find the best configurations for your project. So this could be something like the best configuration of your master plan, so the best orientation of the buildings and the relationships with each other. This could be the best location for your project. For example, if you're trying to get good presence along the side of a road and you want to make sure you get the best presence, or you want to make sure you have good presence but at the lowest cost, these are things that we can do as well. And we also can do things like find the lowest capital cost for your project without affecting the design intent. So how do we do this? How do we have these big grand claims of being able to go through millions of different design alternatives and find great savings and the best, quote-unquote, configurations for your project? Well, first it starts with technology. And here at Beck Technology, we've created a new technology called Destiny Optioneer. So what I'm going to do first is talk to you a little bit about how Destiny Optioneer works. So it'll kind of demystify some of this stuff. And then I'd like to talk to you about what we have to do in order to make it actionable. So what we have to do to make it a service and why we have to make it a service and not just sell it as a technology. So Destiny Optioneer starts out with us working with the design team. We input different design parameters, constraints. We initially focus on what are your goals. So for example, a goal for a project might be to find your lowest first cost, or it might be to find your lowest operating cost, or both. If you want to evaluate more than one goal, we can. On top of that, we then take in the different variables along with their allowable ranges. So for example, you might want to look at placing a building on a site. You don't necessarily know the exact location, so you can move around a little bit. You might want to look at the orientation as well, so we might want to rotate that a full 360 degrees. You might want to look at things like number of floors. So in this case, maybe want to look at anywhere between 3 and 10 floors. You might want to also look at window-to-wall ratio. All these different pieces, different insulation values, low-E coatings, etc. So you can look at how moving your building around the site not only affects things like your civil work, but also your energy performance of the building. So then after we input those design constraints, after we input those variables and their various different constraints, Optioneer will automatically create multiple deprofiler models within those constraints. So we've got a large server cluster that we then farm a lot of this work out to. And on each one of these machines in the server cluster, they're creating many, many different deprofiler models. For each one of those models, deprofiler then analyzes all of the relevant information required on each one of those models. And I think, too, if you're attending this webinar series, likely you've seen deprofiler before and you understand it. But for those of you who are online who maybe this is the first time you've heard about deprofiler, you don't know a lot, I'd like to at least say this about the product. The purpose of deprofiler is to act as a planning tool. It is to basically show the knock-on effect of all of your decisions that you make on a project across as many disciplines as possible. And so this particular technology, the Optioneer, is exactly why deprofiler was created in the first place. Is once you have the ability to show that knock-on effect, you could do things like this, where you can then push that into millions of different directions and start to find really good information. And so in this case, on each one of these machines, when that deprofiler model is created on this cluster, it's looking at different things like your energy analysis, it's looking at your cut and fill, so all your civil work, it's pricing the system, it's taking into account every piece of information that we can to make good decisions on each one of these models. Then after that deprofiler model is created, that information is obtained, we then send that back to the optioneer, and really this is the meat of it. So what we do is once we get back all these thousands and thousands of models, we analyze that data. So Optioneer will take a look at that data. We have very advanced algorithms that get the data back and then make really good decisions on where to explore next. And then we will continue to do this. So Optioneer will continue to do this over and over and over again. It'll create new models. It'll analyze those models. It'll then study those results and then create new models, analyze, and study continuously over and over and over again until it's satisfied that it's explored the design space. And I think at this time, too, it would be good to help define what we mean when we say design space. So at Beck Technology, if you were to create, let's just say you have a building and you wanted to look at rotating that building by 1 degree, a full 360 degrees. Well, that design space is now 360 separate models, right? It's every single model you'd have to model to look at all of the different alternatives. Well, when you look at moving a building around on a site, and you want to look at changing its elevation, and you want to look at rotating it, and at the same time do things like look at changing its cladding, its insulation, any of these other pieces, number of floors, the design space starts to grow exponentially. And so you end up with hundreds of trillions or larger number of possible models that you can create. And the magic of what we have and what this technology can do is it will explore the entire design space. So that is something that if you were to try to, let's say, create one of these models, and you were able to create a model every single second, right, and look at the results and then create the next model, it would take you 5 billion years to try to create all the models for one project. Just to give you some concept of how much computational work is going into this and how much effort it's going to take to use deprofiler with Optioneer to explore the space per project. So then once we've explored that design space, once we've run these thousands of different models, Optioneer then provides us with interactive results. So we actually have an interactive chart that allows us to look at all of the goals in comparison with each other, as well as all of the different variables and the models that we've created in relation to those goals and variables. So, for example, here you can see that we've got a series of different, each one of these dots is a series of different deprofiler models, and they are colored based off of whatever variable it is that you want to look at the time. And this is really good because it lets you see where you can achieve gains, and it also lets you see where maybe you're not going to get as good of a trade-off between certain variables, and the payback's not going to be as high as you might not have expected. And so for us at Beck Technology, when we perform this service, we really focus on the different trends that we see when we run a project through this optioneering service. And that helps guide the design team in making better decisions. So what I'd like to do is give you one of our case studies. So this is a project that we've done for the U.S. State Department. And on this project, we had 4 different buildings. Each one of these were housing buildings, this is residences, an overseas embassy. And what we could do here is when working with them, the objectives that the State Department gave us were to minimize the life cycle cost. So this is total cost. This is first cost plus the cost of operating the building, as well as minimize the carbon footprint. And then the variables we were allowed to use were we could have anywhere between 3 and 4 buildings. We could have those buildings anywhere between 5 and 8 stories tall. And we were able to use the building footprint as any permutation of an H-shaped building. So in this particular case, it could be a rectangle, a square, C, an H for whatever shape you might want to define from this H-shaped building. We were also able to rotate the building a full 360 degrees. We did have some constraints. Obviously, these were residential buildings. They had to maintain the same number of rooms for each one of the total complex. So in this case, we had to maintain the gross floor area. We had to make sure they had the same number of 1, 2, and 3 bedroom apartments. We also had some site constraints. So the buildings themselves couldn't get within 20 meters of each other, and they could not get within 20 meters of the perimeter fence. Security concerns here, so you couldn't get very close to this perimeter fence. And to give you some idea of this particular project's design space, it was 1.46 trillion models. So this is the results. This is one particular view of the results of this run. And what I'd like to show you here is this little X is our baseline. So in this particular project, this is really interesting actually because Beck Technology has a services division that uses products like the Profiler for our clients. And we were hired by the State Department to do the initial work, pricing work for this project with the AE. So in about an 8-month span, Beck Technology services team worked with the AE to come up manually with about 6 different possible options and fully price them. Well, we had a 2-week window between when the design alternatives and everything were finished to when the State Department was going to put this out on the street for bid as a project. And in that 2-week window, we ran through this optioneering service. So we went through the other 1.46 trillion different options. And what I'd like to show you here is maybe a little bit about how we can read this chart. So each one of these dots is a full-blown deprofiler model. And currently, we've got it colored by the different building representations. So for example, the blue here is a 3-building, 5-story option versus the red, which is a 4-building, 8-story option. And again, this baseline, this is the initial building. This is if we didn't do anything, if they didn't make any changes whatsoever between the time that the AE was finished with the design and the time the State Department put this out to bid, this X is what they would go with. So you can see that there are a number of different models that still meet the design criteria, that still meet the scope of the project, that not only are less expensive, but also have a better carbon footprint, so they're better for the environment. And one thing that I'd really like to point out is, and this is something that we genuinely try to look for the most, is a lot of unintuitive results. So a lot of things that you may not have considered and you wouldn't have gotten to without being able to go through and explore large sections of design space. And one of those unintuitive results are these little red dots here, which is basically saying that on a project where you have large amounts of security constraints and the cladding of these buildings needs to have certain levels of blast requirements, that cladding ends up being one of the main cost drivers of these projects. And you would think, conventionally, that having the building with the smallest footplate, i.e. it's the tallest building and the most number of those buildings, would be the most expensive option by far because you've got the most cladding. Right? So your floor to cladding area ratio is horrible. But this shows us there are a number of really good models inside of this design space that are better than our baseline. So here is our baseline. What I thought I'd do is show you exactly what we started with and then a couple of the different options to show you what the design team could choose from as a result of this exercise. So our baseline project, this is a $197 million project. And currently, when we actually worked with Stanford University to help look at the carbon impact. So not only embodied carbon, but actually the amount of carbon that's burned even placing materials. And that was 285 kilotons. So I know it's a bit of a busy slide, but if you look up in the top right-hand corner, this is going to show you the baseline, which is this black X, and then you'll see an orange dot, which shows you the location of the model we're currently looking at. So this particular option was one of our least expensive options, and this particular one was a 3-building, 6-floor option. And in this particular option, we were able to save the client $27 million on this $200 million project. Now, one of the things that I'd like to show is that we did evaluate a number of these different buildings, and they don't all look the same. Now, these first two definitely have very rectangular pieces. Obviously, it's an efficient floor plate, and we can drive down the cost that way. So, for example, this one was a 4-building option, but it still saved them $18 million. And here's another alternative. This is a 4-building with 5 floors, and it's got a little bit more of an articulation here in the footplate, so you can have a little bit more design creativity, but still with a $13 million savings and 6 kilotons worth of carbon. So that was just one example of where we used this, and it was one of our early examples. We've used this quite a bit since then. That happened last year, so we've been using it kind of live on a lot of Beck projects. But the thing to point out is by itself, this technology does not work. As nice as it is to have a technology that you can take and farm out thousands and thousands of different models to a cluster of machines, and it can look at the different alternatives. If you do not have an entire team of AEC professionals guiding this software, it's pretty much worthless. And so this is specifically why at Beck Technology we had to wrap this technology around the service. So we basically you have to partner up with every one of the key stakeholders to be able to effectively use this. So you have to have somebody from the design team involved that can give you the different constraints, the different variables, the things that are on the table to look at. You have to have the pre-construction team involved to give you the pricing for all of the pieces that as you change them, you need to know effectively exactly what's going to happen when that change occurs. You need to have somebody from your project management and construction side there to know how it needs to be built, to kind of help that entire team work together to make good decisions. And all of this information is placed within the Optioneer so that when we run these models, we get good results. So our first step in this services engagement is we work with that project team to determine the different aspects of the project that they want to explore. So this would be the designer, the estimator, the construction manager all sitting down and saying, this is what our project is, and these are the different things we want to look at. So it's okay we want to have a good presence on the road, for example, and we want to be able to move it, maybe left 4 feet or right 5 feet. It can go up and down a foot, but for the most part, it has to be in this particular area. And so at that point, they're sort of defining what the project is, as well as the different constraints that this project has placed on it. Then after we get those constraints and we understand all the different variables, we will then create a deprofiler model of that project and add all of the necessary data and intelligence to support optioneering. So, for example, in the case where we're moving this building back and forth, that building has utility tie-ins, or obviously if we have to move dirt in order to get the building to the position we're looking at, we need to take into account all of those pricing, all of that rerunning of lines, any other piece of information that we need to take into account in order to make those decisions. And so we put all of that intelligence into the deprofiler model ahead of time. Once we have that deprofiler model, we then configure Destiny Optioneer to look at the different variables. So we basically say, hey, we're going to look at moving it right 5 feet, left 4 feet, up and down a foot, and then we kick off the design space exploration. Now, prior to this, working with a project team, that could take a couple weeks depending on how readily available the information is, as well as how easy it is to get everybody on the project team into one room at the same time. But once we have all this information and once we are able to kick off the design space exploration, performing the exploration has never taken longer than a day. So once we perform that exploration, we get the results back in those kind of scatter plots that you saw earlier. And the first thing we do as a team is we try to look for trends and identify anything that's really interesting, any really interesting sections of design space. And so particularly these are the parts where we start to look for things that are unintuitive. So what we like to see, is there anything here that we weren't expecting? Obviously, if you're running a utility line between 2 buildings and you put those buildings closer together, the utility line price should decrease, as should the overall price of the project. But when you start to move those together, if all of a sudden you see a spike in price, or it moves in a direction you weren't expecting, or the energy analysis performs in a way that you weren't expecting, that's when we like to dig in and really start to understand better the design space and why this project is performing the way it does, and then we highlight those trends. So once we've evaluated the results, once we've identified any interesting sections of design space, we then present the results to the project team. And specifically what we do is we create a deliverable packet that kind of showcases interesting design alternatives, as well as any information that the project team might want to look at. So it's not only just, maybe we want to look at the insulation or the levee coating, but there might be some other extraneous information that the project team also wanted to keep in mind. And when we're going through the results, there's some things that may have become more valuable in between the time when we first started this whole design exploration and the time that we're presenting the results. And so we'll not only show them a handful of interesting design alternatives, but we'll also show them all the other information that they might find valuable. And of course, they have access to the other, tens of thousands of models that we've created, as well as the interactive chart that shows them. And so what we do is we continue to do this. We will repeat this process over and over and over again to ensure the success of the project goals. Because what will happen is the design changes, the scope changes, decisions are made, people learn things. So what the project was on day one is not going to be the same as what the project is necessarily before you break ground. And I think this is specifically the part that makes this really effective, is that we will continue to rerun these models, rebuild the models, explore the design space, present back the results over and over and over again as many times as possible to keep that project team as informed as possible, making good, solid, sound decisions. So with that, that is our Destiny Optioneer service and technology.